Hello everyone, welcome to STEM education. I am Syed Wahaj and today we are going to learn physics. We are going to study making measurements for the year 9th IGCSE physics. So let's get started. Let's start with the idea of measurement first. Measurement. Now let's ask this question, what is measurement? And what is it that we try to measure? For example, if I will ask you what is your age, you can give me the answer that I am 16 years old. 16 years old, right? This is answer to the question, how old are you? How old are you? And the answer to this question is 16 years old. Okay. How tall are you? I can also ask this question. How tall are you? How tall are you? You can say, I am 6 feet tall. 6 feet tall, right? And let's ask another question. How much do you love physics? How much do you love physics? Right? So you can say, I love it very much. Very much. So what is the difference in the answer to the three questions here? Here we can measure the amount of time I have lived. So time, here we are talking about time. We are talking about the time. Here we are talking about length. And here we are talking about love, right? But the problem with love is that we can't really associate any number with the idea of love. We can't give it a number, we can't give it a value. So it is impossible to give value or quantity to the idea of love. But when we're talking about the idea of time and idea of length, then we can have the capacity to assign it a number, to assign it a value. So whenever we try to measure something, what is it that we are trying to measure? So the first question that comes to our mind, what is it that we try to measure? What is it that we measure? This is the first question, question number one. What is it that we measure? Okay, this is the question. So the answer to that question would be, we can measure time, we can measure length, good, we can measure force, we can measure, what we can measure? Number of things, we can measure temperature, and also we can measure mass, how heavy you are. So how tall you are, it's about length. When I ask this question, how tall you are, we are talking about length. How old you are, we are talking about time. How much you have pushed something, the idea is about the force. How hot something is, we are talking about temperature. How many boys are in the class, how many girls are in the class, so we are talking about the number of things. How heavy something is, we are talking about mass. So what we have written over here, these are certain physical quantities. These are certain physical quantities. Okay. So the idea that we are going to deal with today is about the physical quantity. We are going to talk about the idea of physical quantity. Physical quantity. Okay. Physical quantity. Right. So what is a physical quantity? A physical quantity is something that we can assign value to. Physical quantity is something that we can measure. So let's write down the definition of physical quantity. What is a physical quantity? It is something, it is something, it is something that we can measure. We can measure. It is something we can assign a value to. We can assign a value to. So that is a physical quantity. Physical quantity is something that we have the capacity to assign value to. Let's ask about what are the different physical quantities. What are the physical quantities that we can talk about? We can talk about length, mass, time, force, pressure, speed, and many more, etc. Okay. So are you able to understand this idea that what is a physical quantity? I think Talha has joined the class. Okay, Talha, can you tell me what, have you understood what is a physical quantity? Physical quantity is something that we can measure. Physical quantity is something that we can give answer to in terms of number. Like how much force you are applying on something. So how much force you are applying on something, if I'm going to ask you how much force you are applying on something, you can assign a number to it. You can assign a value to it. That is why force is a physical quantity. Okay. Got it? Now, what is measurement? How do we measure physical quantity? How do we measure? How do we measure a physical quantity? A physical quantity. This is the question. How do we measure physical quantity? Now, let's start with the basic idea of measuring length. Once we start measuring length, once you get an idea about how we go about measuring length, you will have a pretty good idea about how do we measure different things. So let's measure length. How do we measure length? How do we measure length? Measure length. Okay. This is the first thing that we are going to deal with. So what we do in the beginning, we take a reference value of length. Okay. Let's say there's a straight line which goes from A to B. I think I should rather draw a straight line. Let's draw a straight line. Let's draw a straight line like this. Okay, this is a line, and this is another line. Okay. So here we have two lines. We have a bigger line, the white one, and we have a shorter line, the pink one. Okay. Let's do one thing. Let's give it a name. Let's give this pink line a name. Let's call it Jack. The name of this line is called Jack. So this pink one is Jack. And what do we give name to this white one? We don't really need to give any name to this white one. We have to measure this white line using Jack. Okay, using Jack. Got it? So how do we do that? Let's do one thing. Let's take one Jack, and then there's another Jack, and then there's another Jack. Okay, and then there's another Jack. Okay, and then there's another Jack. Okay, good. Okay. Okay. So let's get started. Mm, 1, 2, 3, 4, 5, 6. Okay. So we have 1, 2, 3, 4, 5, 6 and a half. Okay. How many jacks go into this white line? 6.5 jacks. 6.5 jack. So what we do, we say that length of white line equals 6.5 jacks. Right? Why? Because the pink one is a jack, and this jack is repeated 6.5 times, so that we get a length equal to that, the white line. This is what we do. So what do we call this jack? We call this jack as a unit of length. Unit of length, right? So unit of length, jack is the unit of length. Okay, so jack is what? Jack is a unit of length, right? Jack is a unit of length. A unit of length. It is the reference unit. What is a unit? Unit is a reference which is repeated few times so as to get a value equal to that of the given length. Okay. Now, what is 6.5? 6.5 is the number of times a jack has been repeated. Number of times a jack has been repeated. Number of times a jack has been repeated. We call this a magnitude. We call this a magnitude. Magnitude. Okay. So unit is repeated magnitude times to give the value of length, right? So that's what our method is. So what do we do when we try to measure something? We need two things. The measurement of length requires two activities. Measurement of length. It requires selection of a unit. Selection of a unit and finding out its repetition, right? Got it. So let's look at it once again. Let's look at it once again. Here we have two lines. One line is the white one and another one is the pink one. This is the pink one. This is the pink one. Okay, this is a pink one. Got it? This is a pink one. So there it is. Right. So this is a pink line and this is a white line. This pink line is repeated 6.5 times so that we are going to get the white line. So what do we call this pink line? We gave it a name, jack. We gave its name, jack, right? And this jack is taken as the unit of length and it is repeated 6.5 times. Got it? We can do another thing. We can take another line, which is equal to half of that of jack. Okay? Which is equal to half of that of the pink line. Let's call it crack. Let's call it a crack, right? A jack and a crack. So how much is a crack? Crack is, we make a half of the jack and we are going to get the crack. So this crack, how many times it is repeated so that we are going to get what? We are going to get this white line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, right? So there are 13 cracks in 6.5 jacks. Okay, there are 13 cracks in 6.5 jacks, right? What does it mean? It means that when we are using crack as our reference, as a unit, since it is a smaller unit, it gets repeated 13 times. Whereas the jack, which is a longer line, which is a longer unit, I would say, it gets repeated lesser number of times so that the white line can accommodate both of them. If this white line, it wants to accommodate, if this white line wants to accommodate cracks, it would require 6.5 cracks. And if this white line wants to accommodate jack, it would accommodate 13 cracks. Okay? So if we are measuring the same length, but we are using different units, we can either, it's our choice. We can take jack as a reference and we can take crack as a reference. But if we are using jack, it gets repeated only 6.5 times. But if we are going to use crack, it is going to get repeated 13 number of times. So what is actually happening over here, if we are going to put a little bit of intuition into that, we would find out that for the measurement of a given length, different units can be used. Different units, or in other words, we can say references can be used. Different units can be used. Okay? Example, what are the different practical units? Example, we can have a meter, an inch, a centimeter, a feet, a yard, a kilometer. So these are the different units, different references, which we can use to measure the length. So let's do one thing. Let's take this much of length. Okay. Let's call this is 1 meter. This is 1 meter. Got it? Let's call it 1 meter. Got it? Now what we are doing, we are going to take another reference which is equal to this one. Okay? But we have a special case here. What do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So what do we have here? We have this length, this one, the blue one, and the pink one. Let's call this pink line as a 1 meter length. Okay. So what can we say about this blue length? Okay. Let's call it blue length. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. When we repeat 10 blue lengths, we get 1 pink length. So 1 blue length is equal to 1/10 of a meter. 1/10 of a meter, right? 1/10 of a meter is the blue line. So when we do 1/10 of something, we can call it a deci. What is deci? Deci is when we divide something in 10 equal parts. Anything. Like I'm a man, somebody comes along, he uses a sword and he just starts cutting me down into 10 parts. So 1/10 of myself would be a deci myself. Like my name is Rizvi. My name is Rizvi. So this man, let's say this is who I am. This is Mr. Rizvi. Okay? This is Mr. Rizvi. Okay? This is Mr. Rizvi. And let's do one thing. Let's cut him down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? In how many parts we had the opportunity to cut Mr. Rizvi? Okay? We cut Mr. Rizvi in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So this part of myself, this part of myself, okay, this part of myself is 1/10 of Mr. Rizvi. Or rather, we can call it deci Rizvi. Deci Rizvi. Okay? What does deci Rizvi mean? Deci Rizvi means 1/10 of Mr. Rizvi. Okay. Here comes the conversion factor of units. Here comes the idea of conversion factor. Conversion factors. Right? Conversion factor. Okay. What is conversion factor? What do we study in the conversion factor? When we try to measure something, when we want to measure a particular length, we want to use a unit. Okay? If I'm going to ask you, what is your height? You can say, I have a height of 183 centimeters, or you can give me answer in inches, you can give me answer in feet, you can give me answer in meters, you can even give me answer in kilometers. So there are different units which can be utilized to answer the question, how tall you are. But if, for example, I know I am 100 meters tall, let's say I am 2 meters tall. So I am 2 meter tall. Okay. Then how many centimeters there would be? There would be actually 200 centimeters. Why? Because in every meter there is 100 centimeter. Okay. So 1/100th of a meter is a centimeter, or 100 times a centimeter is a meter. So we can say that 1 meter is equal to 100 centimeters. Okay. Now this 100 is known as conversion factor. This 100 is known as conversion factor. Why? Conversion factor. Why? Because if somebody is telling me, tell me 500 centimeter, okay, 500 centimeter, that would make 5 meter. How do we do that? We divide this 500 by 100, and then we are going to get 5 meters, right? So in order to convert centimeter into a meter, if I want to convert centimeters into meters, what would we have to do? We have to divide the value in centimeters, like we have 500 centimeters, then we have to divide the value in centimeters by 100, and then we would be getting the value of it in meters. Okay, That is why we call this 100 as conversion factor. That is why we call it a conversion factor. So if we are going to divide a centimeter, how many centimeters we have, by the number 100, we are going to get how many meters we're going to have. So these are the conversion factors we need to be very careful about while changing the units, while changing. Initially, we were trying to measure something in meters, then we were trying to measure something in centimeters. So when we measure something in centimeter and when we measure that thing in meters, we divide it by something, and that something with which we are going to divide that particular thing is known as a conversion factor. Okay. So let's discuss in a little bit of detail. Okay, if you want to really, I would really want you to give me a thumbs up or give me an indication if you have understood up to now. Is there everything that you have understood, or do you want me to give a little bit more elaboration on something? I'm really looking forward to that. Is there anything that you would want me to repeat? Salah. Am I audible? Can you listen to me? Okay, let me see. Yes, Talha is there. Talha, can you listen to me? Okay. Okay, never mind. Hello, am I audible? Talha? Okay, okay. Thank you. And have you understood everything that I've told up till now? How to measure things, what is measurement, what is units, and how do we convert one unit to another, and what is the idea of units, and what is the idea of preference when it comes to the idea of measuring lengths. Have you understood that? Yeah, is there a question that you want to ask? If there's a question that you would like to ask, just go ahead. Just go ahead. Okay. Okay. So let's start with conversion of certain things. Like there's a metric system, and we call the list of prefixes. Prefixes, right? Prefixes. Let's call some prefixes. Let's call it deci. What is deci? Deci is 1/10. Okay. So if I'm writing decimeter, decimeter, what would it mean? It means 1/10 meter. Or if we are going to write it in exponential form, it would be 10 raised to a -1 meter. Okay. So 1 decimeter is 1/10 of a meter, or 10 raised to the power -1 meter. You understood that? Hello, got it? Tell me, what does a decimeter mean? A decimeter means 1/10 of a meter, and or we can, if we convert 1/10, we can write it 10 raised to the power -1 meter. Okay, so we have here a deci. Deci means 1/10, or also we can write 10 raised to the power -1. So a decimeter means 1/10 meter, or 10 raised to the power -1 meter. Then we have a centi. A centi. What does it mean? It means 1/100, or 10 raised to the power -2. Right? So 1 centimeter. 1 centimeter equals to 1 over 100 meter. That means 100th of a meter, or 10 raised to the power negative 2 meter. So what we can say, a centimeter is 10 raised to the power negative 2 meter, or 1 over 10 or 10 raised to the power negative 2, right? So we have talked about two prefixes. Why do we call it a prefix? We call it a prefix because it is used before the word meter. Meter is there, and before meter, we are writing deci. So we write meter first, and before meter, we are writing deci. That's why we call it a prefix. We call it a prefix because it is used in before the actual word. So 1 centimeter is 1 over 100 meter. Why? Because the word centi itself, it means 1 over 100 or 10 raised to the power negative 2. Right? Got it. So now we have an idea of what is a deci and what is a centi. Then we have another prefix, that the name of the prefix is milli. Milli. What does milli means? It means 1 over 1000 or 10 raised to the power negative 3. What is 1 millimeter? 1 millimeter. What does it mean? It means 1 over 1000 meter, or 10 raised to the power negative 3 meter. Right? So it is 1 millimeter, and milli means 1 over 1000. And 1 over 1000 can be written as 10 raised to the power negative 3. Got it? So we have written, okay, let's write it down. If you want to write it down, I can give you time, a little bit of time. Take a little bit of time and write down. These are very important things. These are the different prefixes that we use in day-to-day life. 1, 2, 3, and we have certain prefixes. I'll let you do all of those. After that, it will be like easy for you to understand. Fourth, deci, centi, milli. Then we have micro. Micro. It is 1 over 1, 2, 3, 4, 5, 6. 6 zeros after 1. We call it 10 raised to the power negative 6. Okay? So 1 micrometer is 1 over 100,000. So it's like it's a million. 1 over a million. It's a million. It's a million thing. A millionth part of a meter. A millionth part of a meter. A millionth part of a meter. Or 10 raised to the power negative multiplied by a meter. This is called a micrometer. So in 1 meter, there would be a million micrometers. In 1 meter, there would be a million micrometers. Or in other words, if we are going to divide 1 meter into a million parts, a meter is divided into a million parts, then 1 part is known as a microparticle, micrometer. Got it? Then it's a micrometer. Got it? So deci, centi, milli, micro. Let's write it first. Nano. So nano means 1 over 1, 2, 3, 1, 2, 3, 1, 2, 3. 9 zeros. 10 raised to the power negative 9. That's a nano. Sixth, pico. Pico. It means 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We are increasing 3 zeros again and again. Not 1 0, not 2 0, 3 zeros. Again, we are increasing zeros by 3s. Okay? So it's 10 raised to the power negative 12. Pico. 7. Femto. Femto. Femto is 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 10 raised to the power negative 15 femto. Then eighth one is atom. Atom. What does it mean? It means 1 over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We are increasing 3 zeros in each step. So it's 10 raised to 1 negative 18. Okay? So these are the different prefixes. These prefixes actually decrease the value of something. These deci, centi, milli, micro, nano, pico, femto, atto. These prefixes are basically dividing into pieces what we are having. Then we have another prefixes which are actually increasing. Let's write them down as well. Let's write the first prefix, let's call it deca. Deca means 10. Okay, so let's say we are talking about 1 decameter. 1 decameter. It just means 10 meters. 10 meters. Okay, a deca means 10 times. You are not dividing it, you are multiplying it, you are increasing it by 10 times. And when we are talking about the deci, we are actually breaking it down. When we are talking about deca, we are multiplying it, we are increasing it. And when we are talking about the deca, we are increasing it. When we are talking about deci, we are decreasing it. In deci, we decrease. In deca, we increase. So decimeter is 1/10 of a meter. A decimeter is 1/10 of a meter. A decameter is 10 times a meter. Okay? It gets repeated 10 times. So a deca is bigger, a deci is smaller, right? A deca is bigger and a deci is smaller, right? Now deca means 10 times. The second one, hecto. Hecto means 100 times. Okay? So what would be a hectometer? A hectometer would be 100 meters. A hectometer would be 100 meters. So let's write it down. Let's write all those we know. 1, 2, 3, deca, hecto, then kilo. Kilo means 1,000. So when we say that we are going in kilometer, in 1 kilometer, 1 kilometer means 1,000 meters. 1 kilometer means 1,000 meters. And 1 kilogram, it means 1,000 grams. 1 kiloliter is 1,000 liter. 1 kiloliter is 1,000 liter. And just 1 kilo. Let me tell you that if somebody asks you to give him a kilo of pen, a kilo of pen, this pen, a kilo of pen, you are going to give him 1,000 pen. Because kilo means 1,000. If somebody asks you to give a hecto mango, let's say hecto mango, what does it mean? Hecto mango means 100 mangoes. What does it mean? A deca mango. Deca mango. Deca mango means 10 mangoes. Deca book means 100 book. So when we say deca, we multiply it by 10. We say hecto, we multiply it by 100. We say kilo, we multiply it by 1,000. Right? When we say deci, we divide it by 10. When we say centi, we divide it by 100. When we say milli, we divide it by 1,000. So that is the difference between deci, centi, milli, or deca, hecto, kilo. Right? Okay. Okay. So we have deca, hecto, kilo, 4. Then we have mega. And mega is 1,000, then 1,000. Right? 6 zeros. That's a million basically. So deca is 10 to the power 1, hecto is 10 to the power 2, hecto, kilo is 10 to the power 3, mega is 10 to the power 6. Giga, giga, right? Giga is 10 to the power 9. Again, we are increasing by 3s. So gigameter, a gigameter is 10 to the power 9 meters. That's way too big. That means you put 1, 2, 3, 1, 2, 3, 1, 2, 3, 9 zeros in front of 1. That would make a giga. These many things are giga things, right? 6. Deca, hecto, kilo, mega, giga. Then we have tera. Tera means 10 to the power 12. Then we have exa. It's 10 to the power 15. Zeta. So these are the different prefixes. Okay. Now let's do a few questions on this. Let's ask a question. We are given 1,000 nanometer. Okay. 1,000 nanometer is equal to how many kilometers? Right? 1,000 nanometer would be how many kilometers? This is a question. This is a question that if we have a 1,000 nanometer, how much it would be in kilometers? Okay, so we don't know the answer to this question. Let's do one thing. Let's write x kilometers. Let's say the value of 1,000 nanometer would be x kilometers. Okay, so it's a very easy question. From now onwards, it's a very easy question. Let's do one thing. Let's write down all the numbers that we have. 1,000, let's write it down in 10 to the power 3. Do we know the meaning of nano? Yes, we have written the value of nano is 10 raised to the power negative 9. And then meter, right? Okay, and then let's write something here. We have x, and then we have a kilo. What is a kilo? A kilo is 10 to the power 3 meter, right? So this is something which we have on the both sides of equation. What do we have both sides of equation? We have 10 to the power in the left and 10 to the power 3 in the right. So the thing that we are having in both sides of the equation, we can just cancel it. And we are remaining with x meter equals 10 raised to the power minus 9 meter, right? So we have meter to the both sides. We can cancel meter as well. So the value of x is going to be 10 raised to the power negative 9. So that is the answer to this question. So 1,000 nanometers would be 10 to the power minus 9 kilometers. 10 to the power minus 9 kilometers. Okay, let's write another question. Let's write another question. 100 decasecond is equal to how many milliseconds? Milliseconds, right? How many milliseconds? Right? So here we have 100 decasecond, and we are going to have some milliseconds, right? So a decasecond is going to be converted into a millisecond, right? Okay, so we have, okay, good. Okay. So 100 decaseconds, that is equal to some milliseconds. I don't know how many milliseconds we are having here. Let's try to figure it out. Let's write it x milliseconds. We have x milliseconds in terms of 100 decaseconds. Let's try to convert it. So 100 can be written as 10 raised to the power 2. 100 can be written as 10 raised to the power 2. And what does deca mean? If we remember, a deca means 10 raised to the power 1. And then second, right? Then we have x here. And what does milli means? Milli is 10 raised to the power negative 3. And then seconds, right? So what do we have same in both the sides? We have seconds here, we have seconds here. Okay? Then what we can have? We can write it 10 raised to the power 2, 10 raised to the power 1. It is 10 raised to the power 3 equals 10 raised to the power negative 3 into x. Got it? Now what we can do? We can divide both sides by 10 raised to the power negative 3. 10 raised to the power negative 3. What would happen? This 10 raised to the power negative 3 would get cancelled. And since it's in denominator, when it goes in the numerator, it becomes 10 raised to the power 3 into 10 raised to the power 3. That becomes equals x. So 10 raised to the power 3 into 10 raised to the power 3, that makes 10 raised to the power 6. So what is the value of x? It's 10 raised to the power 6. Got it? So if we have 100 decaseconds, it means we need 10 raised to the power 6 milliseconds. Okay? It is 10 raised to the power 6 milliseconds. So today, we actually studied about the units and we studied about the length and the prefixes. These are certain things that we need to be careful about while dealing with the conversion. And if there is any question that you would want to ask me, just go ahead, fire it up. I'd really like to answer those questions. And after that, we'll have the next class. In the next class, we'll be discussing further from this. Okay? Do you have any question that you would like to ask? Is there any point of confusion that you're still having? Okay, so I think it's okay. It's done for today. We can have next class tomorrow. As per the schedule, I guess you must be having the schedule with you. So we'll be having class in the next class. Okay. Thank you so much. Thanks a lot.